Today we are going to look at Chapter 4, Section 3, Solving Equations by Adding or Subtracting. You have already worked with the additive inverse of a number when you subtracted integers. Today we're going to solve equations by using the addition and subtraction properties of equality. We will also translate verbal sentences into equations. An equation is a mathematical statement that has an equal sign. Solution is the answer to a mathematical statement with an equal sign. Solving the equation is the process that we will go through to find a value for a variable. Inverse operation, addition and subtraction are inverse operations of each other. Equivalent equation is a different form of an equation, which is also, of course, equal. Okay, so here you go. You have the addition property of equality. Basically, you start with the idea that you have two things equal to each other. And when you know that two things are equal to each other, if you add something to both sides, you are maintaining the equality. So then 13 equals 13. If you look at it here, you have some number minus 5 equals 10. By using the addition of 5 to both sides, you have an additive inverse here. The net effect is negative 5 plus 5 is 0. That zeroes out and leaves you with just this y. What you do to one side of the equal sign, you have to do to the other. So 10 plus 5 equals 15. I like to tell my students that I want you to think of an equation as a balanced teeter-totter, and this is the fulcrum point. This side is balanced to this side. If you do something to this side, you have to do it to this side as well in order to maintain that balance. So if we add 5 to get rid of this minus 5 over here and get the y by itself, you also have to add 5 to this other side. Okay, we're going to solve x minus 4 equals negative 3. First off, start by writing the equation out. We are going to add 4 to both sides because it is the operation that is its opposite. Since it's minus 4, the additive inverse, or the inverse operation, if you will, is plus 4. Add it to both sides. You get x plus 0. You can see where the 0 is coming from. And over here you have negative 3 plus 4, which is a positive 1. So the answer then is x equals 1. And you're going to check that. So you start off with x minus 4 equals negative 3. You plug the 1 in because that's what we found the answer to be. 1 minus 4, the question is, does that equal negative 3? And yes, it does. So we have found the correct answer. X is 1. And to graph that on a number line, you just simply put a number line down and put a dot on the 1. Okay, now we're going to do the same thing with decimals, and it's going to work exactly the same way. You're going to start by first writing down the problem. Negative 8.4 equals n minus 6.1. Now we are going to add the 6.1 to both sides because we want to find out what n is. We've got to isolate n and get it by itself. Since this is minus 6.1, the inverse operation is adding. So we will add 6.1. What happens here is this cancels each other out. You're left with just 0. And you have negative 8.4 plus 6.1, and you get negative 2.3 over there. So the value for n is negative 2.3. And graphing that on the number line, it's somewhere between negative 2 and negative 3, somewhat closer to the negative 2. Okay, this one is yours to try. The original problem is x minus 7 equals negative 3. And then they would like for you to graph the solution on a number line. You should have chose option C. If you add 7 to both sides here, you'll end up with x plus 0 equals negative 3 plus 7. Negative 3 plus 7 is a positive 4, and positive 4 is located here on the number line. And now you're going to do this one, and notice this time it's with decimals. Okay, you should have chose D. The inverse operation here of subtraction is addition, so you're going to add 3.8 to both sides. You'll end up with m plus 0. Then you have negative 7.1 plus 3.8. That becomes negative 3.3. And of course, that is located somewhere between negative 2 and negative 4 on the number line. Okay, now we're going to do the same thing, except for we're going to be utilizing the subtraction property of equality. Concept is the same. You start with two things that are equal to each other. Oh, I'm sorry about that. You start with two things that are equal to each other. You subtract the same thing from both sides of the equal sign, and then you should still have something that is equal to each other. Over here, we start with n plus 4 equals 9. The inverse operation of addition, of course, is subtraction. That's why we chose subtraction here, because plus 4 minus 4, those will zero out, leaving you with just the n. What you do to one side of the equal sign, you have to do to the other in order to maintain that equality. So 9 minus 4 leaves you with 5. Okay, and here we go with our first problem. We have 32 plus y, or equals y plus 12. Start by writing the original problem down. Since we were adding 12 initially, the inverse operation, of course, is subtraction. So instead of adding 12, we will subtract 12 from both sides. Positive 12 minus 12, those will zero out, leaving you with just y equals 32 minus 12 is 20. And here they're going to go through and check the equation. For y, we replace it with 20. And yes, indeed, that works out. Okay, do the same thing now, except for this time you're using a decimal, but it's going to work exactly the same. You begin by writing out the equation, and then since x is being added to 6.9, we're going to subtract 6.9 from both sides. That will allow this side to become just x plus 0, or x, and over here you have 4.2 minus 6.9. Now, these work just like they did before. You can use a calculator if you want to help you get that negative 2.7. And this time we plug in the negative 2.7 into the equation for x and see if it works, and it does. Okay, this one is for you to try on your own. You have 14 equals t plus 5. Remember, you want to use the inverse operation of addition. You should have subtracted 5 from both sides and found t to be 9. And do this one on your own. You should have selected choice B. Using the inverse operation of addition, you would have subtracted 4.8 from both sides of the equation and got negative 3.3. Okay, the Driscoll Mountain with a height of 535 feet is the highest point in Louisiana. Just for a little FYI, we're about 900 feet above sea level here in Indiana, and so you can see that this mountain in Louisiana is not as high up or as far away from the sea level as you are. It is 8,214 feet lower than Guadalupe Peak, which is the highest point in Texas, which is actually further above sea level than you are. Write and solve a subtraction equation to find the height of Guadalupe Peak. Okay, obviously h will be the height of Guadalupe Peak, and we don't know that, so of course that'll be the variable. We know that if we take the height of Guadalupe Peak and subtract from it this 8,214 feet, that we should end up at the same height as the Driscoll Mountain in Louisiana. And you can add 8214 to each side, because that'll be the opposite operation, or inverse operation, if you will, of minusing. And you will end up on this right side with just h, and over on the left side with 8,749. That should be the height of Guadalupe Peak. And this one you can do on your own. I'll give you a few minutes to read through this, figure out the equation, and then solve it. Okay, and you should have chose option C. And that's the end of the lesson. At this point, I need for you to return to my big campus and see what it is that you need to do next.